All right. Honors Algebra 2 and Algebra 2. Here is your last assignment for Chapter 8. Please write down everything you see here. Honors Algebra 2 and Algebra 2, Chapter 8 test review. Very good job to the folks that are submitting things early. Several of you, especially in Algebra 2, have already sent in their game plans for Chapter 8. You guys all received the email from me about how I'm putting in your grades and how long they'll stay like that. And any work, folks, it's simple. Any work that does not get submitted to me, your name's going to go on an incomplete list for quarter 4, and we're going to take it from there. That should not happen because everything is online and all the answers are here, and you just need to have it down for when I see you again, either this school year or if I see you again in another math class. If you're moving on to pre-calculus, then you definitely can't throw this stuff away. You will be expected to know it well. Folks, write down numbers 1 through 6. Find any points of discontinuity for each rational function. Find any points of discontinuity. Pause it whenever you need to. For each rational function. All right, so here's number 1. That's the rational function right there. Okay, so here is your question. Y equals x plus 3 over x minus 2x plus 6. You're going to set the denominator equal to 0. Discontinuous point has 0 in the denominator. Set x minus 2 equal to 0, x plus 6 equal to 0, as I've done over here. You get x equals 2, you get x equals negative 6. Now, you're not naming them. You're not going to name it a vertical asymptote or a whole. You're going to say what makes that denominator 0. X equals 2 and x equals negative 6. Again, if you want full credit, which you do, which is very easy to get, you write down the full question like I have it here, and then all the work that I showed there. Y equals x minus 5 times x plus 2 over x squared minus 9. The denominator, set the denominator equal to 0, folks. That's how you find your discontinuous points. X squared minus 9 equals 0. X squared equals 9. Take the square root. X is plus or minus the square root of 9. X equals plus or minus 3. X equals 3. X equals negative 3 are what makes the denominator equal to 0. Those are your 2 discontinuous points. Here's number 3 right here. Y equals 9x times, or not times, but divided by x times x minus 4. Set the denominator equal to 0. Well, you have x equals 0. And x minus 4 equals 0, or x equals 4, your 2 discontinuous points. Number 4, y equals 7 over 3x minus 2. Set the denominator equal to 0 to find your discontinuous point. 3x minus 2 equals 0. Add 2 to both sides. Whoa, divide by 3. X is 2/3. Number 5, you have y equals 5x plus 4 over x squared minus 25. Set x squared minus 25 equal to 0. X squared equals 25. Take the square root. X is plus or minus 5. Set y equals 13. So you have y equals 13 over 5x plus 11. Set 5x plus 11 equal to 0. 5x equals negative 11. X is negative 11 over 5. Those are the discontinuous points. What makes the denominator 0? Now, on 7 through 9 here, it says, so write this down, 7 through 9, describe, emphasis there, the vertical asymptotes, can be a hard word to spell initially, and holes for the graph of each rational function. Here's number 7, folks. Write down number 7. Just like before, we're going to set the denominator equal to 0. X minus 2 equals 0. X plus 4 equals 0. You get x equals 2. And x equals negative 4. In the previous 6 examples, we would be done here. But you have to describe what type of discontinuous point each value of x there is. x minus 2's cancel. From the game plan, if you have turned in, you know that if something gets canceled or covered up, it is a hole. You can cover holes up. Something that does not get canceled, well, then it is a vertical asymptote. X equals -4 is a vertical asymptote. And that's the name of the game on 7 through 9. Here's number 8. Y equals 5x over x times x plus 3. All right. Set x equal to 0. Set x plus 3 equal to 0. Always set the denominator equal to 0 first. You get x equals 0 and x equals -3. Cover up or cancel out the x's. Notice how the x is canceled. That means x equals 0 is a whole. X equals -3. It did not get canceled. It is a vertical asymptote. Number 9, y equals x minus 4 over x squared minus 16. How does the denominator factor? That's what we want to do here. If I have to describe the discontinuous points as vertical asymptotes or holes, I need to factor the denominator. X squared minus 16 factors to be x plus 4, x minus 4. So I'm going to set this x plus 4 equal to 0. Set that x minus 4 equal to 0. I get x equals -4. And I get x equals 4. Then I look to see if anything cancels. Can you see anything cancel? I think those cancel. Because they cancel, that x minus 4 equals 0, which means x equals 4. That is a whole. X plus 4 did not cancel. So x equals -4 is a vertical asymptote. And that section there is done. On 10 through 15, folks, please write, simplify each rational expression. Again, simplify each rational expression. Here's number 10. 10x plus 50 over 10. Now, that's the question, so write it down just like that. You can divide everything by 10. What I'm going to do is up top in the numerator, I'm going to factor out the 10 that 10x and 50 have in common. When I factor, I'm dividing, so then I'm left with x plus 5. 10's now cancel, leaving you with, you guessed it, x plus 5. Number 11, 8x plus 24 over 3x plus 9. In the numerator, I can factor out the 8 that they have in common. In the denominator, I can factor out the 3 that they have in common. Doing so gives me 8 times x plus 3 over 3 times x plus 3. Cancel out the x plus 3, you're left with 8/3. Here's number 12, x squared minus 36 over x minus 6. Factor the numerator, x squared minus 36 is going to leave you with x minus 6x plus 6. The denominator is x minus 6. Cancel what they have in common. Final answer, x plus 6. On, what was that? That was 12. Here's 13. You have x squared plus 8x plus 15 over x squared minus 9. Factor the top. What multiplies 15 adds 8. X plus 5, x plus 3. Factor the bottom. Well, as a difference of two perfect squares. X minus 3, x plus 3. Cancel out the x plus 3s they have in common. Left with x plus 5 over x minus 3. Number 14, x squared plus 17x plus 72 over x squared plus 12x plus 27. In the numerator, what multiplies 72 adds to 17, x plus 9, x plus 8. In the denominator, what multiplies 27 adds to 12, x plus 9, x plus 3. Cancel out the x plus 9s, leaving you with the x plus 8 over x plus 3. Number 15, x squared minus 25 over x squared plus 7x plus 10. In the numerator, you have x plus 5. Or how's that factor? That's going to be x plus 5, x minus 5. Divided by x plus 5, x plus 2. Cancel out what you see north and south that are the same. X plus 5 over x plus 5 cancels, leaving you with x minus 5 over x plus 2. All right, for video number 1, I think we're going to stop there on 15. Video number 2 will be coming up at you shortly.